which I have listed it down over here. So what is WebSphere Message Broker? As Swamiji told that you have already worked as support, so I think that you are aware of that it is based on MQ. It is based on the top of MQ. Previous, what was the history of Message Broker? Was earlier it was made by one of the company called Neon, and in 2000, nearly in 2000, one company called Cybease overtook Message Broker and then followed by IP. So I think this WebSphere Message Broker, not as an WebSphere Message Broker. Okay, I got it. You have already an experience in the book. So I'll just give an overall little presentation about what it's about. So it's built on MQ, and you can do transformation, routing, enriching, all stuff in Message Broker. It's the high volume processing. As you might have seen, production of lots of messages will be coming in MQ, and you process them in 3 minutes or 4 minutes of time. So it's a high volume processing. It follows lots of protocol and standards. It's a intermediate tool which is used for integrating the different application which is running on different platform or different hardware. So this is all about a small generic information about this Message Broker. Standard protocol in the sense you can have industry and vendor protocol, or you can have IBM protocols like which are all listed over here: HTTP, TIPCO, FTP file, TCP IP, simple mail transfer protocol, or Node for mainframes, SAP, PeopleSoft, and these all are the vendor specific. When you have HF7 or Swift, which is used for banking and all, you can use. So a simple example how you can understand a Message Broker is like, suppose you are as a shopper, you are a client over here. Previously, when integration tool was not there, Message Broker was not there, it was point-to-point connectivity. So if you want to talk, online store want to talk to retailer 1, it has to be a direct connection between online store and retailer 1, or retailer 2, or retailer 3, and retailer 4. So in that case, online store has to code for each and every retailer to communicate with that particular retailer. If I place an order, then it will go to retailer 1. Place an order for retailer 2, it will go. So retailer 1, you can say it's like it's a mobile shop. Retailer 2 could be a clothing shop. Retailer 3 could be a generic stuff like electronic laptops and all. So like that you can have multiple retailers. So when you're going in an online shop, you just place the order. Message Broker gets the detail, and Message Broker based upon your content of the message, like you shop on mobile, it will route it to retailer 1, or retailer 2, or retailer 3. This is how Message Broker comes in. It's a two-way communication, like online store can talk to Message Broker, and Message Broker can talk to retailer 1. So what are the other benefits of using Message Broker? So obviously it's very good as compared to point-to-point communication, because so much of complexity has been reduced because using of Message Broker. So some of the benefits are listed over here. That reduce the coupling. It decouples the senders and receivers. So only senders and the receivers can be able to communicate with Message Broker. No other person can enter inside and hack or make it slow system. So sender communicate with the Message Broker, and the potential grouping of many receivers under a logical name is transparent. So sender just sends a message, and Message Broker takes care of everything. Sender does not have to worry about whether the receiver is up or running, or who is the receiver. So this is a reduced coupling. You can improve the integrability, of course, because if you add a Message Broker, you can have so many levels of integration about it. Modifiability. So what happened is previously there was point-to-point communication. If anything happens, anything changes from the client side, online store, and if anything happens, if any modification needs to happen on the receiver side, like retailer 1, so you have to code for that. So what will happen if you use Message Broker? We can directly change all the message settings, whatever you want to change in Message Broker itself. You don't have to change the online store, or you don't have to change the retailer store coding. You can just have to transform, route, or enrich whatever you want to do the Message Broker. Whatever message that is coming, what is the requirement? Like mostly you will have a requirement called transform the data. Some message is coming in a tree structure form. You might be aware, like everything what comes in a Message Broker is a form of logical tree structure. So if in the later point of the class, I'll tell you what all tree structures are. So if the tree structure is coming inside a Message Broker, you can convert into some other tree structure and send it lot of details, but your retailer does not want all the details which you are sending from online store to retailer. You want only a specific amount of information, like what is your name, what is the product you ordered, or what is your billing amount and all you paid. He does not need all your address information or what is your prescription, what are your various things. The retailer does not need to know. So what you do is you cut short the messages and send it to retailer. So this is what you do it in message broker. You, based upon the content of the message, you route it to different retailers. So this all things comes in message broker. So availability. So a single component should be available, and you can pinpoint where is the problem happens. If there's some single application point of failure, a secondary message broker. Basically, it says like one message broker will handle so many requests. There will be a scenario in production support, I believe, like there will be a slow in processing. So that time you will increase the instance of the message broker. You can deploy the flow in a 2 execution group, or you can make the instances of the flow as 2 or 3 to increase the product throughput. And it reduced the performance. Reduce the performance means improve the modulability and improve the security. So in security in the means only the sender and the receiver will be knowing like how to handle and what all data is being passed. No other third party is in between, to handle the particular security of the component. But you will not be knowing what is going on. Only message broker, sender and receiver will be communicating with each other. These are the benefits of using message broker. Definitely there are liabilities also, like increased complexity, which I told, like one message broker would be handling all these requests and responses. So if a lot of applications are dealing with message broker, then obviously there will be complexity. This is one of the complexity which says increased complexity. Increased maintenance effect. These all are related to the things when we have lot of amount of processing available, like lot of application A and application B's are interconnecting with message broker. So these are liabilities will come in. Like that what availability I have said, like if there is only single instance of message broker and it goes down, then will be a problem with availability, but message broker will not be there. And same like performance. So these all 4 things are related to the things when you have large bulk of messages or bulk of applications which are joined together with message. So if I'm clear, this point, can you check? But can you? Sorry, I'll contain it. Divakar, is this fine for you till now?
Hey, Akash, go ahead, Akash. Okay, just send you guys. It's not a problem, just go ahead.
So message broking. So these are the things you can see from the message broker, like you have an application A. So you might be aware of the queue managers also, right? Because the message broker is built on top of the queue manager. Whatever message that you put inside a message broker, internally there will be a queue in which the message will be stored. So when you put a message, it will go in some particular queue, which will be an IBM defined queues, which you can see like system.broker. Some queues. So whenever you put a message, it will go to the queue and you will again put in some output queue and you will process. This is one of the scenarios you can implement in message broker. So what basically happens, suppose you are an application A, you put a message in a queue which is handled by queue manager A. So what is queue manager? Queue manager is managing stuff. It manages all your queues, your data and connectivity with the queue. That's why we'll have a queue manager. It's the heart of a queue. We call it a heart. It's a runtime entity. So an application A puts a message in queue manager A, and then suppose it says that comma separate. So you're putting a message in which the data are separated by comma. Okay. So you will have a flow. You will define a flow which will be deployed in an execution group which comes under some particular group. That's why it says queue manager broker 1, the component filter, you can transform it to different locations. So it has a filtering node, and then you have two compute node. What it does, it converts your comma separated value to XML format and CWF, so content wire format. So these are the two of the formats which are available in Message Broker, and you send it to MQ input out, MQ output, and you will see that application B is running on wall and application C is expecting XML message. So you can see you are sending a message in comma separated, and finally the message that is received in application B is content wire format and XML format. This is the simple overview. You might be aware about how the message broking stuff works. So what are the various kinds of processing nodes that are available? You can receive and route the messages, transforming a messages to an alternative representations, selecting a message for further processing based on message content. This is what we are doing. Then you can interact with databases and all. You can augment your message and send it to other applications. And you can respond to events and errors. So if any exception and all is there, if any exceptions and all are there, then you can handle it. So move to the next slide. It's all about business integration. So I'll skip this part because these are all things you are already aware of. So this is what I explained in previously: route a message, transforms a message, stores a message in a database, retrieve a message from a database, modify the content of the data, then publish a message. So publish is also one of the very good functionality you can achieve in Message Broker. For an example of publish, you can see like quick info. So whenever you have a message match going on, like currently India match is going on, West Indies. So what publish message is like, you publish the messages to the customers. You publish the messages to a customer with a topic saying that quick info match status. So what will happen when you publish it? Some other customers will be there which has to register to this particular topic. So who all customers are registered, they'll get this status message like saying this much run India. So what is the functionality? Like you just publish it you just publish in the cloud, and whichever customer which are registered to that particular topic, they'll receive the messages. So this is one of the very good functionality that you can achieve it in Message Broker. Then you can have Tivoli as a monitoring tool, which was there in version 6. So in which version you are currently working? Yes, version 6 or version 7 or version 8? Okay, you are working in support version. So you have an idea about version 6, like how the version 6 was there. How many years of experience you have for this particular support? Okay, a year and a half. Yeah. Okay. Thanks. So you might be aware of everything which I have said. Probably then you are looking for the development perspective, a better approach how to develop a message flow, better approach to tune a message flow. So these are just general stuff which you are aware of everything. So you might be aware of this architecture. This is the 6 architecture, in which you had a configuration manager in between the message broker toolkit and broker. So when you deploy your message flow, this configuration manager helps in deploying the messages to this particular broker. So now you are working in, yeah. So now you are looking for version 7 and 8 onwards. So in version 7 and 8 onwards, you might be aware there is no configuration manager as such. So they have removed the configuration manager, and you can directly deploy it to the broker. So you can directly deploy the flow. This is a component change which happens from version 6 to version 7 or 8 onwards. So you might be aware also that there is one more version 9 which has come up this is the component. You might be aware what is toolkit, what is broker. So I'll not go much in that in toolkit and broker, but you are already aware of this. So toolkit, broker, group into broker domain. So these all are the same steps you must be aware of. Okay, then this will be interesting for you. So message broker components. I was telling about there will be a logical tree. So every message is whatever message you are sending, whether XML or whether comma separated value or whether HL7 or whether shift domain for business, banking domain. So whatever message that you're sending inside the flow, once the message comes inside the flow, it will get converted into form of logical structure. So this is how it will be represented. Message input tree. Yeah. So this is how it will be available. An input message tree in the form of so if you want to extract any information, you have to write an XPath. You XPath instance you might be available like with this with dot like a dot b dot name. So this is how you have to extract information from a message. So whatever you are seeing will be an input message tree, and then there will be nodes. So you might be seeing a lot of nodes while if you're opening any message flow, you'll be seeing lots of nodes are there. So this is one of the nodes which says compute mode. So you will have an input terminal and you will have an output terminal. So input terminal, the message comes in the input terminal. Yeah, built in. So okay. You have input terminal and you have an output terminal. So output terminals, there will be multiple output terminals. Which one of the output terminal will be out? Everything goes successful, it will go to out. Then there will be failure and there will be catch. So and there will be catch. So if there is any exception occurs while coding inside the compute mode, it will go to the cache terminal. If you did not handle anything in cache terminal, it will go to failure terminal. If you don't handle failure terminal also, it will roll back to the previous location and keep on rolling back until it finds the cache terminal. If you don't write by default, the starting point which is MQ input will have a cache terminal. So it's all like coding in Java, like there is an exception, we keep on rolling back until unless there is an exception being caught. Same like that, here also is the same. This is built on Java only, Eclipse tools. So everything, whatever you see internal is a Java code on. So this is, I was explaining, input tree, input message tree will come in. You will do some enriching or transformation over there in the compute node and built-in nodes, and you will get an output. Either you don't want the structure to be changed or either you want the structure to be changed. This is what a simple explanation how we process using compute node and we have changed the structure. So basic input node and compute node and output node is there. So this is how you will see an input message, the stream is coming. So everything which comes in the form of bit stream format, like in Java, everything that you input in the form of string pattern. Here also everything that comes in the form of string only. So everything comes in the form of bit stream. When it comes to here, what you are seeing threads with graphic cards. This is your message, and it gets converted into form of, this is comma separated. You might think that there is a comma in the message, and what comes in output is an XML based message. So let's see what is happening. So once a message comes in bitstream format, it gets converted into form of tree structure. So what makes the message to get converted into a tree structure? There will be a parsers. So there are a lot of parsers in message broker. One of the parsers is like XML parser, XML NS parser, XML NSC for namespace and compact, MRM parser which was there till version 7. Now in version 8 they have removed. To develop an MRM parser, they have come with a parser called DFDL parser. There will be a SOAP parser and GLOF parser. So these are the, and more parsers are there, HL7 parser, SWIFT parser. So these all parsers are available, which converts the message parcel will generate the physical into logical. Correct. So whatever that comes in a bitstream format, it converts into a logical. used by message broker. Then it comes to our compute node. So in compute node, we write some code to transform it to some other structure, some other logical structure. Again, it will go to our output node. Again, whatever message that gets converted into logical structure, right? Again, it has to be converted back into the string format. So again, the parser will convert the logical structure to the string format. So again, then it will go to the output. So this is a very generic scenario which you will see. This is an overall picture actually. Basically, if you leave about the nodes and all, like various nodes, this is basically a message broker do. The message comes in, converts into logical structure, it processes, it gets the value from that logical structure using XPath, defining an XPath, and you transform the message or route the message, and you send it to an output queue. Again, in the output queue, again it gets converted in the form of the string format from logical to the string, and it goes to the output application. So the overall generic scenario, it's very easy. Message broker is very easy. If you write code and all, right, 1 month or 2 months, you will have a pakka hand in writing codes in message broker. It's not very tough, very easy. So you'll see this is a generic scenario. So this I was talking about. So what happens? You might be aware of, like when the message comes in, you'll see there will be headers. I'm aware, like, are you aware of this? Like, what are the different headers? Are there properties, MQMD headers, and body will be there? Have you ever seen the production support, whether you have put any trace node and all, and you have seen any headers like that? You have not seen. This is a very important thing, Divakar. Like, whenever the message comes in, as soon as the message comes into the queue, input queue, the message, see, you will have some ID, right? Every message will have an ID, a unique ID, through which a message will be categorized. That ID, the time the message comes in, start time, the application that has put the application, putting applications. So these all details will be added to the message in a header format. This is what I'm saying. Like, in the later class, when I'll show you a demo about using the nodes, I'll show you like how the header looks like. So first will be properties, and then will be MQMD, which says message queue, message description, and followed by the payload. So this is how your message goes in the form of tree: properties, MQMD, and then body. Okay. So I'll tell you what all properties have and what all MQMD have, and the body will have the message that you are injecting inside the message. So this is a very important thing for a lot of transformations, and you do using properties. You will set that property and it will get transformed. So this is how I am saying logical message in a broker. So there will be a root, which is the head, which is from a tree. XML, you can see as the root as the head, and then inside you have a message properties, and you will have MQMD, and you have a lot of other headers also, MQ or HFQ headers, then XML. So properties will have so many values. One of the 3 listed values are message set, message type, message format. These 3 are very important if you want to create a dictionary. It means like suppose by default there are so many parsers available. But if you want to create your own data structure, if you want to create your own parser, like if you want the message that is coming, you want to parse according to your requirement. So in that case, you have to create message set, message type, message format. So this is available till version 7. In version 8, they have made it like message models. Instead of calling it a message set, they have made it in a message models. So what all things will be there in MQMD? Format, the message will be persistence or not, whether the priority of the message. So these are basic information will be there in MQMD. And then you will have a body which will be an XML message. If you're injecting an XML message. So various parsers that are available are XML, XML-NS, XML-NSC. So NS will namespace. XML-NS means namespace. XML-NSC means the compact namespace. HL7, IDOCS, MRN, log, MIME, and GMS and all. So these all and more parsers are available. physical means in XML what you are sending it order name having first name, last name, item, quantity, price, date and order. So you'll see order, same like you create a tree structure. Order will have a name, will have an item, will have a quantity, will have a price and date. Name will have first name and last name. So if you want to access the first name first, then you can have order.name.first. So this is how if you write, then you will get the John. I'll give you a demo when I'll give you a demo about how to create a notes and all, in which we'll see like how to access name, how to change the first name John to Divakar or something like that. This is how the physical message looks like, logical message inside node, inside the message broker. For XML, like that you can have CSV. So whatever comes in, like XML comes or CSV comes, comma separated value comes, or custom messages, your built-in custom messages come. It will all get converted in form of logical tree structure. So this is what it says, same logical tree regardless of format, making it easy to add new formats. So whatever that comes in, it will all get converted in a form of logical order only, logical tree. So this is the tree structure. So it says different options for creating message models. So message model is nothing but you are creating a data structure. So you are creating a data structure of the message, like how the message that comes in should be passed. So there could be a scenario where a message is coming in, but before the message as soon as the message comes in the node, if you want to check whether the structure of the message is what is as per the requirement. What you will do at that case, you will add this structure in that node, saying that please validate my message with the structure that I have provided. So what will happen? It will validate your message or message format or message tag and say it's same as according to the data structure that you have provided. If it validates, it will move to the next node. If it does, it will throw an exception. So you might have, if you have tried to open a flow and all, and if you have seen, there could be a scenario where they are checking the message formats while the message at the first point itself they are checking the message formats. So what here we see is a different option for creating this model. So message broker, Parsers, message set. So you can create a message model using C header, a COBOL copybook, or visuals, XML, schema, document type definition. You can directly import this whole thing and directly create a message model. So you will have, client will be giving you a C header class, a particular text file or something. Like that they will be giving a COBOL copy file. Like that they will be giving a visual. So what you have to do is you just have to import this file and automatically a message model will be created. So you don't have to manually create message models for these all things which will be directly imported. Like that for SAP, SQL and PeopleSoft also you will be having their message models. And pre-built. Pre-built means already there is a pre-built like SOAP, MIME, CSV. Already a message model available which are pre-built. So you don't have to import it. Or you can define your own. Or you can define your own structure saying that the name that is coming, the first name, I don't want the first name to be the first entity. I want last name to the first, and then first name to be the second. So you can build your own message models. And then there is WTX. WTX is also one of the applications which you have to buy separately from IBM, which also helps for making a transformation. So this for handling complex transformation, we go for WebSphere transformation extender. Till this time, did you understand how the message gets converted into logical structure and the way it is processed? Okay. Okay, thank you. It's very tough, it's audible, you're not able to audible, so anyhow we'll manage this. Probably next class, I'll be able to hear what you're saying, so we'll communicate much better. So whatever I explained previously, see, this thing what I'm explaining is a very generic thing, and you should be aware of this all this, because these things only will make the base for developing a message flow. When you go to the code wise is very easy. If you are stuck up in some of the code, you can directly go for help content, the message broker. They have provided help content also, and you can type and you can find the code. So developing flow is not very easy. It's very easy. This thing which is more important is these particular basics. How to create a message set and what all headers are there, what all changes you have to do for headers, and then writing a code is very easy. So this is the same thing which I was telling you previously. You import these all files and it will generate a message set for you like this. And this message set can be used in the SQL or mapper node also will be there, which is used to map from one node to another node. And you create a message dictionary. This message dictionary will be used by particular node. This is the way. Don't get confused with this particular slide. But the same thing which I explained you previously. This is the same thing which they have shown in more graphical way. So this one, yeah, okay. So this one is the same thing which has root properties and MQ. I'll explain you when I'll explain you the code. One of the examples, when I'll give you an example probably in the next session, then I'll explain you what is root, MQ, and MRM. Again, the same thing, logical message model, MRM, message set type. See, don't get confused. MRM is also one of the parsers available in Message Broker till version 7, not in version 8. It still supports MRM, but you cannot create MRM in 8. You have to create DFDL parser. The DFDL parser, which is more dynamic parser and which is not just for Message Broker. You can use it externally also. So this is one of the MRM parsers which was available in version 7, which you had 3 of the supporting model, data format description language, CWF, anti-CDS, and so on. So this is the same thing. You will see root, MQMD, MQRHF2, and body. So root will have message set, message type, message format. The MQMD will have reply to queue on which format the next particular child will have, and then MQRHF2 header. So MQRHF2 header will be there when you use JMS application and all. At that time it will get populated. Otherwise, this particular MQRHF2 will not be present in message itself. So basically, you will see you will have properties, then you will have MQMD, and then you will have a payload. So this is how when the message comes in, it looks like this only. The root followed by properties, followed by MQMD, and followed by body. So this order is the correct order. You cannot put MQMD before and then properties. No. Properties followed by MQMD and followed by body. Or sometimes if you use HTTP nodes and all, you will not have MQMD. You will only have properties and followed by body. MQMD will always be there only when you use queues. So when the message comes in a queue, that time it will create MQMD. So the message that comes in will always have body only. The first point of contact, the message broker will add properties in MQMD based upon the flow level. Okay, don't get confused. What I'm saying, if the message comes in with an HTTP node, then you will have properties. Message broker will add properties, and then you will have a payload body. If the message comes in MQ input mode, then you will have properties, you will have MQMD, and then you will have body. This is how they have defined it. And the most important thing, it is based upon the MQ thing. So it will process single message at a single time. The first in, first out is the process that it follows. So until and unless the first message is not cleared, it cannot process further. So message will be stuck. So in production support, you might be checking what message got stuck and why the message is stuck. So you have to remove the message and then it will start processing. So this is how it is processing. So exactly one message process per flow instance. Multiple alternative paths are also available. You can deploy your flow, multiple flows, deploy the same flow into incubation group or two different brokers. Then you can have multiple alternative paths. So whatever message that comes in particular instance will be processed in that instance only. It will not pass to other flow instances. Okay. Okay. So I'll tell you, like in this particular slide, we see like the sources for message flow. So this is nothing with respect to coding. Like you have to create message flow projects, broker schema or message flow, and you go for creating a message flow. So it just says content from message flow. This will be more suitable when we'll start creating a message flow and then deploying and testing it. So I'll not take this slide as of now, and then I'll also show you how to debug a message flow. So there is a very good client application, inbuilt application they have provided. You can debug it like in Eclipse. If you have done the Java code, you can debug, and the API will be there for debugging. Like that, we have API from version 7 onwards. It was not there in version 6. We have a particular API. You can add your breakpoints and you can test it. So adding breakpoints means it will stop at that particular point and you can see what is the content of the message, what was the input and how it get transformed in particular node. So these all things you can monitor in that particular API, test line say. And what are the built-in nodes that are available in message broker. So these are some of the few built-in nodes available. WebSphere MQ, which we have input, some of the input and output nodes, HTTP, JMS output database, MQ set, XML transformation, and try catch node, and some of the more nodes available. This weekend, when we start creating message flow, then we'll be more clear about the properties of each node. The properties of each node is very important. Writing a code, as I told you, is very easy. Only the property of the node, you should be aware of what the particular property of the node does. Everything lies in message broker is the properties only. So you should know all the properties of the node, and then writing code as I told is very easy. So these are one of the few nodes which are available: MQ input, output, MQ reply, MQ get, MQ optimize. So MQ optimize they have removed from version 8. But these are the four main MQ nodes. Then you have JMS nodes, input, output, reply, transform. Then you have HTTP for web service, HTTP input, reply, request. For SAP you have input, output, and request. So for web service again you have SOAP input, SOAP reply, SOAP request, SOAP envelope, SOAP extract. These all are some of the SOAP nodes. Then you have for routing and transformation you have printer node, have a label application node, route label. So these all nodes will look one by one classes how to use this particular label node, a route label node, and out node, and printer node, and mapping compute node only you will basically write the business scenario where you will write any SQL code, you will change the whatever requirement you have to do. So everything, all the coding stuff will be there in compute node. If you're related to Java code, if you have a Hibernate and all, and if you want to interact with database, you can write your Java code and you can inbuild. You can use that particular code using Java compute node. Then you have an input node and output node. You can also have a subflows like sub modules created in Java or some C and C++ like that. You can have a subflow also over here, which create a subflow, then you can use it multiple times. It's a reusable component. So if you have a reusable component, your first starting point will be input node. That's what it's in input node. Then you can use trace. Trace is one of the important nodes which is used for handling the exception. So you will put a trace in between of the flow, and in the Unix you can see what is the particular value. It's for tracing. No one will use this particular trace node in the flow level. When it goes live, you have to deactivate the trace because it uses the memory, it uses the time frame and all. So it's just for testing purpose only, and no one, it does not go in live. When you put the message flow in live, you remove the trace node and give it the bar file. And then you have reset content. To reset your content, to reset your domain or parser, this is one of the nodes. And timer node also is there. Suppose a batch load and batch update. Suppose you want to start the flow only at 1 o'clock in the night. So you can have a timer node which say like start the message at 1 o'clock. Whenever it becomes 1, your message processing will start. So that and all you can do with timer node. So, some of the few nodes which are very important for error handling. Okay, yeah, for error handling you cannot say trace for error handling. Yeah, you can have a trace node. See, that's what trace node is for your perspective. Like if you see something goes wrong, you put a trace node over there and see like what is the content that is coming. But you will not find out the error thing from trace. It just shows the content. So if you want to find out the error, you have to go for user trace. User trace in the sense when you deploy the message flow in Unix, obviously there will be some components, a trace will be generated. I mean, trace in the sense processing, step-by-step processing. Like first it went to input node, then it went to compute node, compute line by line. Will have a solution like first it went to first line, then second line. That also is available in the user trace. That is Unix level, in which you can find out like how the flow is getting processed. So if any error is there, you can go and find. It's a little tedious, but it's very helpful. Trace, you can use it for error handling, but to some extent. Trace you can use. Okay. For message transformation from this particular format to that, you will have a mapping or XML transformation, or compute node or Java, compute node or WTs. So some of the transformation nodes are available. So I believe for you also it is same. You will develop, you will test, insert, and then you will deploy in QA. Then you might have a production, or you can have a DNS environment, and then it goes through production. So this is how also the particular user roles will be do. As a developer, we develop message flow, message model, etc. We unit test in local machine and create a path file and give it to you guys, and you guys will be doing all QA stuffs and production stuffs. So deploy a bar file. I'll not be telling you deploy a bar file because you are already aware of how to deploy a bar file because you are working on production support. So I'll skip this particular part. So this is now more, I'm coming more into the development perspective, like how you input and output, what all the properties you can see, what all message set, message type, message format you can set. So this probably I'll take it in the next class when we are more going towards the developing of the flow, more going to the development perspective. So which has some properties I have listed over here. Some compute node properties, some small basic set of commands that we can write, and a logical structure. So I'll also tell you what are the tree structures that are available. So everything that comes, I have told you, is in a tree format. So there are message tree, environment tree, local environment tree, and exception tree. So these are the list of trees which are available in WMV. It plays a very important role in WMV, these all trees. So everything that goes will be around trees only, either message tree, environment, or local detail when in the development perspective. I'll tell you about local environment tree. I'll tell you about exception tree. What is the list of exceptions I'll tell you. And then I'll tell you how to handle errors. So how we'll handle an error, what is the scenario for handling an error, and how the message flow behaves when an exception occurs. So this particular flow chart is very important flow chart which tells about exception handling. This I'll tell you. Then audit error and email framework. This is just an example for auditing, and already there will be built-in notes in the sense of customized notes which the client will provide for handling audit logging and all, because you might be checking the logging when you check when you process it, some message gets stuck, you go and check logs. That is already there. You might be aware of this. We'll create subflows for that. We have IP sub-initialized like this. We have in our project. I am not aware like this. You also have not. Some exception codes, then push subscribe format. So this is the basic steps which I'll be telling you about that. And the more you learn when you go through the development perspective, when I'll show you how to import particular nodes in the flow, how to process the nodes, how to trace the flow. So these are more steps you will be learning when I go through the development perspective. As for the demo class, so this is all I have to say.